welcome to this last series of webinars related to the PV market. Before we get to the formalities, I just quickly want to play you this. I know it's some contrast for what we started off with. So this is my son, grade 3, was playing in one of other Eisteddford, his piano class, and we talk a lot about work and what he does at school. And the one day after he played piano, and I told him about the CPT webinar coming up, and I had to explain to what Cirprotec is. He asked me, Dad, so if an orchestra plays outside in a thunderstorm, who will get struck by lightning first? And I said, I've got no idea, my son. He says to me, the conductor. So a clever boy for 3 years old there. And I can also tell you that I'm 100% sure that he inherited all his looks and his intelligence from me, because I've got nothing left. My name is Christo. Start the webinar then. So the presenter is Enrique Tornell. He is the sales area manager for CPT, looking after North Europe, East Europe, as well as MEA. So that means he looks after us, helping us, supporting us on technical, sales, and every other matter that we need. He's always been there for us. If we need to phone him after hours, he's always willing to assist. So Enrique, from my side, thank you very much for the time that you offered up for us and supporting us in this field. And thank you. So the floor is yours. Please strike this guy with lightning and see what we can teach them.
Thank you, Christo. Amazing introduction. And thank you for Ross, Dumi, and the whole Electromechanicas team support. So welcomes for today's webinar focused in surge protection devices into the PV market. As Christo said in the amazing introduction to this webinar, I am the sales area manager in Cirprotec, managing the North Europe, East Europe, Middle East, and Africa. Before officially start with today's webinar, I thought interesting to share with you something came out to me recently. This information is coming from Eskom, South Africa's power utility. In the last days, they shared something about the rooftop solar, mainly for residential, commercial, and industrial. And they are stating that the capacity installed in South Africa was increased from 983 megawatts in March 2022 to 4,412 megawatts in June 2023. It means around 3,429 new megawatts PV rooftop capacity installed in South Africa during this period. Let me take the assumption, the guess, about 100 SPDs installed per megawatts. This data is coming from different projects we are working worldwide. And with those figures, we get a total amount of SPD installed within that period, around 342,000 SPDs. This slide is just focused in rooftop solar installation. So if we would take also into account the PV power plants installation features, the whole picture demand will be even increased. With so, the purpose of this first slide is just to share with you that we have in front of us a great opportunity to catch up together in South Africa. We have the chance to live with the responsibility to assure that the right protection level to the PV installations we are in position to take care about, with the main aim to bring the best medium and long-term outcome to the end users' investment in PV. After this quick snapshot about the situation of the PV rooftop in South Africa, let's start officially with the webinar itself. First, we will manage a quick introduction to the surge protection and the operation of the surge protection devices. Then we'll move on to the surge protection solutions for PV installation based on the ISC international standard 61643. And the last part of this presentation, I will share with you Cirprotec product overview to cover the market needs. In order to understand the functionality of an SPD, it's fundamental to know what do surges mean. Surges are transient overvoltages that can reach tens of kilovolts in a duration of the order of microseconds. The energy content can generate premature aging of the electronic components, equipment failure, and disruptions to service and financial losses. How does a SPD work? A SPD is an electrical component that should be installed in parallel to the equipment to be protected. In a normal scenario, the SPD works as a high impedance component. It means that no current flows through the SPD in a normal scenario. In case of overvoltage, the SPD gets close to zero impedance by diverting the overvoltage to earth. The key here is to be sure the SPD selected is the proper one to protect our installation, is to assure that the residual voltage the SPD is flowing through the equipment to protect after the discharge is below to the maximum voltage the equipment to be protected is able to withstand. Which are the conditions may cause transient overvoltages in a PV installation? The first one is the one named as conduction. Conduction means direct lining straight to the external lighting protection system, what is the lining rod of the installation of the building, or lining slashes near to the buildings and or the PV installation. Then we have another condition named as induction, which means direct straight near to the location and lining induced currents distributed into the electrical network. And the last condition may cause transient overvoltages in a PV installation are the internal surges. Those are overvoltages created by the distribution network, as the utility grid switching, motors turning on and turning off, or electrical accidents. Now, we'll check together the way the standards are stating to simulate the amount of energy depending on the origin of the surges. Let's start with the scenario shared before about conduction. In that case, the standards set up a current waveform as 10/350 microseconds, which means that in 10 microseconds, we're getting the 90% of the total amount of energy, and in 350 microseconds, it's reduced by 50%. Then, in the scenario of induction or internal surges, the standards set up a current waveform named as 8/20 microseconds, which means the same, that in 8 microseconds, we are getting the 90% of the total amount of energy, and in 20 microseconds, it's reduced by 50%. If we overlap the two waveforms, we do see that the most dangerous scenario to take care about is the one coming from conduction. Now it's time to check together the main SPD features in the PV application. Let's start with the common parameters to the AC and to the DC side of the PV installation. The first one is the IIMP, which means the maximum current the SPD is able to withstand one time in the waveform of conduction. Then we do have the Imax, which means the maximum current the SPD is able to withstand one time in the waveform of induction or internal sources. As a third parameter, we have the IN. This is the nominal current, which means the maximum peak current the SPD is able to withstand around 20 times in the waveform of induction or internal sources. And the last one is the UP, that is the residual voltage in between the terminals after a nominal current discharge, which was the IN, the previous parameter defined in this slide. Now, let's move on to the specific parameters applicable to the SPDs installed in the DC side of a PV installation. Here, we have two main parameters to have in mind. The first one is the UCPV, which means the maximum continuous operation voltage can be applied permanently to the terminals of the SPD. And then we'll have the ISCPV, which means the maximum short circuit current capacity the SPD is able to withstand. Now that we've checked together the parameters shared in the labels certified by each SPD we are working with, we are in position to share the different types of SPDs based on the standard ISC 61643-11. The first one is the SPD type 1. The SPDs type 1 should be able to discharge current ratings coming from direct lining stride impacts, which was the parameter shared before, named as conduction. The parameter belonging that should be shared by the SPDs type 1 is the IIMP parameter. Then we do have the SPD type 2. Those SPD type 2 should be able to discharge current ratings coming from induction or internal sources. The parameters belonging to the SPDs type 2 are the IN and the Imax. And the last type available in the market is the SPD type 3. It's not really typical, applicable for PV installations, but it's important to have it in mind just in case we face a scenario where this SPD type would be required. The SPD type 3 should be able to bring a really fine protection level to protect sensitive equipment connected to our installation. These SPD type 3 are tested under a specific waveform named as 1.2/50 microseconds. The parameter belonging to the SPDs type 3 is the UOC. Then, in the market, there are already SPDs combining different SPD types. The first one is the SPD type 1+2. What does it mean? an SPD type 1 plus 2 is an SPD that has to be tested under the type 1 and the type 2 parameters. For type 1, it should be shared and tested under the IGIMP, and for the type 2, the SPD type 1 plus 2 should be shared the IN and the IMAX into the SPD. Then we do have the SPDs type 2 plus 3, which has to be tested under the type 2 and type 3 parameters. IM and IMAX for the type 2, and the UOC for the type 3. It's time to go through the surge protection solutions for the PV installations. Before going in deep to this topic, let me share with you the ISE standard to follow up in PV. The international ISE developed years ago a specific ISE standard to follow up for PV installations. There is one, that is the 61643-31, specific for the product itself. It's defining the parameters all the SPD manufacturers should follow up to be sure we are manufacturing the products according with the standards. And then the ISE launched as well a specific standard finished by -32 that is focused in the installation principles to guide every installer focusing PV to be sure they are installing and protecting each PV installation according with the standards statements. Let's move on to the topic about what is a PV installation according with the ISE. According to the ISE, there are two kinds of PV systems defined. The first one is the PV system located on the top of the building, which is named rooftop. Then there is another kind of PV system defined as per the ISE, that is the PV systems located on the ground, like free field power plants characterized by multiple earthing and meshed earthing system. The PV installation term, according to the ISE, is used to refer both kinds of PV systems. The term PV power plant is only used for extend free field multi-earth power systems located on the ground. Which are the transient overvoltages effects in a PV installations to take care about? Transient overvoltages can destroy directly the PV installation, can cause malfunction of the PV installation itself, can generate premature aging of the PV installation components, can launch disruptions to service, and the main important one, can generate financial loss by not fitting the end user's return of investment. That is the key why the end users are focused to install PV into their infrastructures. Which is the equipment we should take care to protect? The first one is the inverter, even the AC and the DC interface. Then we should take care about the PV array. Also, all the wiring belonging to the PV installation. The components installed in between the inverter and the PV array. And the last point, the equipment for controlling and monitoring the PV installation. Now that we are focused and we understood what should we protect in a PV installation in front of sources, it's time to move on the different type of PV installations according to the ISC, focusing the installation features, the one finished in -3.2. The first one, there are PV installations without an external LPS. The LPS, let me remind you, that is the lightning rod, the external protection system of the PV installation. Then we do have PV installations with external LPS when the separation distance is maintained. This case is excluding the multi-earth solar systems, such PV power plants. And then the last PV installation type the ISC is defining is the PV installations with an external LPS when the separation distance cannot be maintained. This case is including the multi-earth solar systems such PV power plants. Let me inform you, just in case you would need to check and for your reference, the topic about the separation distance. The requirement belonging to this distance are clearly defined as per the ISC 62305-3. Now, we will check together each of these three types of PV installations according to the ISC and how they should be properly protected in front of sources according with the standards. Let's start with the PV installation without an external LPS in place, without a lightning rod in place. Here, you see a drawing where sharing the PV array, the PV inverter, and the main distribution board with the different earthing systems in place. The ISC standard states as mandatory to install the SPD in the location 1, close to the PV inverter. According to the ISC, in this scenario of type of PV installation, it should be a DC SPD type 2. And then the other SPD defined as mandatory to install is it the one in the location 3, close to the main distribution board. This one is an AC SPD type 1 or type 2 or a type 1+2 as we've seen in the previous slides. Then there is an additional SPD that could be placed in the location 2. This one will not be required if the distance in between the SPD in the main distribution board, the one located in the location 3, and the inverter is below to 10 meters. Or if the inverter and the main distribution board are connected to the same earthing bar with a cable length equal or below to 0.5 meters. For example, a case, this one is when the inverter is located inside the main distribution board. Then there is an additional SPD required in the location 3, in the location 4, close to the PV array, that should be a DC SPD type 2, and this one will not be required if the distance in between the inverter and the PV array is below to 10 meters. Let's move on to the second PV installation type defined as per the standard, with an external LPS in place when the separation distance is maintained. I remind you that this case is excluding the multi-earth solar systems such PV power plants. In that case, we do have in the location 5 the LPS installed in the lining rod, and in the location 6 the LPS down conductor. Then the standards state as mandatory to install an SPD in the location 1 close to the inverter in the DC side of the PV installation. That should be an SPD type 2. And then it should be installed in the location 3 in the AC side of the PV installation, an SPD type 1. In the location 2, it would need to install an SPD type 2, but this one will not be required if the distance in between the SPD and the main distribution board and the inverter is below 10 meters, the same as in the previous slide, and or when the inverter and the main distribution board are connected to the same earthing bar with a cable length the same or below to 0.5 meter, like when the inverter is located inside the main distribution board. Then we do have an additional SPD requirement in the location 4 close to the PV array. That should be a DC SPD type 2, and this one will not be required if the distance in between the inverter and the PV array is below 10 meters. Now we'll check together the last PV installation type according with the ISC. This one is with an external LPS when the separation distance cannot be maintained, including the multi-earth solar systems such PV power plants. In that case, we do have the same as before the LPS, and in the 6th location, the LPS down conductor, and it represented by the letter E, the separation distance not maintained, which means that we are in front of a non-insulated LPS. In that scenario, it's required to install an SPD in the location 1 in the DC side close to the PV inverter, should be a type 1. Also in the location 2 in the AC side of the inverter, an SPD type 1. The same in the location 3 close to the distribution board should be installed an SPD type 1. And the last one in the location 4 close to the PV array in the DC side of the PV installation, an SPD type 1. The SPD in the location 1 and in the location 2 should be installed as close as possible to the inverter. Then the SPD in the location 4 should be installed to assure the proper level of protection in front of sources, should be installed as close as possible to the PV array. And the last point, in general, the SPD in the location 2 and in the location 3 are required except when the inverter and the main distribution board are connected to the same earthing bar with a cable length equal or below to 0.5 meters, as when the inverter is located inside the main distribution board. In such case, the SPD in location 2 will not be required to be installed. Now that we've reviewed together the different PV installations according with the ISC international standard, it's time to go through Cirprotec product portfolio. Before going in deep to the product we are manufacturing, let me manage a quick introduction about our company. We are based in Barcelona, in a city named Tarrasa, in Spain, and we are pioneers in the design and the manufacture of lining and overvoltage protection devices. Cirprotec has been manufacturing high-quality solutions for over 30 years. Since 2014, we are part of Mersen Group. Mersen Group is a global expert in electrical specialties and advanced materials with around 40 manufacturing sites worldwide. Before going through the next slide, I would like to say that we are really proud to say that we are in close collaboration with Electromechanica as their exclusive partner in surge protection devices since more than 15 years. In Barcelona, in Terrassa, in the city close to Barcelona in Spain, where we do have our manufacturing site, we have our whole product management, project management, and engineering team in-house. We are also we are lucky to have as well lab test facilities in-house. That is one value added we are bringing to the market as manufacturer specialists in surge protection devices. With those facilities, we are able to manufacture and to test our equipments according with the ISE and UL standards. We have in-house a current generator for ISE and UL SPDs, and we do have as well a voltage generator for ESE. Now that we are all aware about who we are as Cirprotec and our close relationship with Electromechanica, focusing the South Africa market, let's move on to the DC SPD product portfolio we are owning in our program. We do have DC SPDs type 1+2. We are also manufacturing type 2 DC SPDs, also multi-pole MPPTs SPDs type 1+2 and type 2. And we are also focused to manufacture direct SPD sockets to be installed into the PCBs, mainly focused for OEM manufacturers. In order to avoid going deep to this all the data shared in this table, I've prepared a couple of slides with our top runners SPDs for the DC side of the PV installations. The first one is our SPD type 1+2 product range. This is our PSC PV product line in Cirprotec. We do have solutions for 1000 volts DC and for 1500 volts DC as well, according with the market needs worldwide. This product line is tested under the IIMP 5KA for the type 1 test requirements, and then for the type 2, we have an IMAX 40KA and an IN 20KA. This SPD is sharing as well the parameter ISCPV, which was the maximum current withstand capacity in case of short circuit, about 10 kA. It's manufactured under the standards ISE in an international way for the EN in Europe, and is certified under the UL, and for sure is CE marked. And the second top runner DC SPD product line we are manufacturing is the SPD type 2 product range. It's named as PSM PV product line in Cirprotec. We have solutions for 600 volts DC, for 1000 volts DC, and for 1500 volts DC. It's declaring an IMAX 40 kA and with an IN 20 kA. Those are the parameters belonging to the type 2 SPDs. Then the same as our type 1+2 DC product range, it's tested and we are declaring an ISCPV of 10 kA. The same, it's manufactured under the ISE and the IN standards, is UL certified, and is CE marked. One of the key value parameters of our DC product range is that our range does not require a backup fuse. In a photovoltaic installation, the current is limited by the amount of PV panels installed in the installation. Therefore, the short circuit current ratings will never be as high as in the AC network installation applications. In fact, the maximum values are typically below 10 kA in a big solar plant. With so, the ISCPV parameter we are declaring as 10 kA in the both product range, 10 kA is enough to assure that our SPD in the PV application does not require a backup fuse. Then let's move on our AC product portfolio. This AC product portfolio is not only common for PV applications. It is also applicable for other markets as building, industrial, water treatment, projects, telecom solutions, etc. But also to protect properly the AC side of the PV installations. We do have pure type 1 SPDs. We are manufacturing type 1 plus 2 SPDs, type 2 and type 2 plus 3 SPDs, and also type 2 plus 3 SPDs with EMI filter. The same as before. In order to go through this tough table with all the technical data, I've prepared to you a couple of slides with the top runners products we are successfully selling worldwide, and the same in South Africa thanks to our partnership with Electromechanica and all the efforts they are doing to successfully promoting our product range, as well as to keep a certain level of stock locally to assure the best service to bring to the customer channel. The first one is the type 1 plus 2 product range. It is our PSC product line. We have solutions with an IM 25 kA, with a 12.5 kA, and with 5 kA as well for typical specific PV applications. We are declaring for the type 2 test an IMAX of 65 kA and an IN of 20 kA. This product range is suitable for TNS, TNC, and TT networks, as well as for IT networks with special reinforced SPD solutions that can be also applicable for PV applications close to the inverter. We have solutions with local and remote end of life signaling, and the cartridges are reversible to be sure we are fitting whatever installation requirements of our installers. Then we do have the type 2 product range. It's named as PSM 40 with an IMAX of 40 kA and an IN of 20 kA. The same as the type 1 plus 2. It's suitable for networks, TNS, TNC, and TT. We do have as well special reinforced SPDs for IT networks. And we do have solutions available for local and remote end of signaling according with the different requirements of our customers. The same, the cartridges are reversible to assure the better suitable installation process. Then we'll have as well our 2.3 product range, that is our PSM 20 with an IMAX 20 kA, with an IN 10 kA, and declaring a UOC parameter for the type 3 test is 10 kilovolts. Those are suitable for TNS, TNC, IT, and TT systems. We have also solutions available with local and also with remote end-of-life signaling. And the same as before, those are reversible chassis. And the last one this over as well a type 2 SPD, 2+3 SPD, sorry, with an EMI filter. What does it mean? An electromagnetic interference filter for a specific application when it is required. It's declaring an iMax 20 kA and an IN 10 kA. At the end, for the type 3 test requirements, it's declaring a UOC 6 kilovolts. Before finishing this webinar, I thought interesting to share with you something about the PV picture worldwide in comparison as well with South Africa pictures. I just started the presentation sharing with you the potential we do have in the rooftop applications in South Africa. Now let me share with you something taking also into account the potential about the rooftop plus the PV power plants in South Africa. This information is coming from Bloomberg. Bloomberg stated that per day in a worldwide level in 2023, it's installed above 1 gigawatts per day, what is absolutely a really good figures according with the global focus in PV generation. If we check the top countries contributing to these figures, we do see South Africa there. With the data Bloomberg is sharing for the Q3 2023, it seems that it was installed 5,000 megawatts in 2023, which means if we compare in between 2023 and 2022, an increase of 400%. If we make the same exercise as I did in the first slide of this webinar, if we take in consideration the assumption of 100 SPDs installed as an average per megawatt, we get a potential of 500,000 SPDs installed in South Africa in 2023. As I said before, we have a huge opportunity to catch up together, as well to be sure we are protecting the installations in solar in the proper way. To be sure that we are assuring the return of the investment the end users are putting in place. Thank you very much for your attendance. Hope it was interesting with you. And thanks so much to Electronicanica's team again for the support by organizing these webinar seasons, as well as thank you for these 15 years working together and looking for many years to come as well.
Perfect, Enrique. Thank you very, very much. It's a pleasure dealing with you and Cirprotec for the last 15 years. So from our side as well, thank you very much. Yeah, we ran a bit over our time frame, but I thought it was very interesting. I'm not going to cut you short on that. Hi, I've got a question. So we're a bit limited on our Q&A session, but no problem. So
I do apologize.
No problem. No problem. We've got a question here. Why does the PSM20 have 320 volt max L to N UC and the PSM40 has a 270 volt max line to neutral UC? The inverter supply asks for 265 line to neutral protection.
Well, can you repeat the question, please?
Okay, I'll try and go slow.
I will go to the slides also of the products you are saying. Tell me.
PSM20 have a 320 volt max line to neutral UC rating, and the PSM40 has a 270 volt max line to neutral UC rating. So the customer is asking that the inverter supplier asks for 265 volts line to neutral protection.
Yes, here we are talking about the iMax, and we are not talking, and this is something I can share with you afterwards, about the voltage these SPDs are working on. Here we have some data. So you were referring to the PSC product line. We do have solutions up to 400 volts and 690 volts as network. I don't know if it is answering your question.
So what we'll do is I'll get Chris and we'll discuss this with him offline, and we can answer his question.
Yes, if you can share it with me by email, I will reply everything to you in order to get the clear data for your customer.
100%. And then Nayasha is asking, what is the significance of 1030 microseconds or 820 microseconds on an SPD data sheet? I think you did run through it in the beginning, so we'll share the presentation showing that the 1030 is more direct in light strike, and the 820 microseconds is the more surges caused by transient over voltages.
I can go right now if you want to.
You can.
Yeah, here. So you are referring, if I understood well, the questions about these waveforms, right? The 10350 and the 820 microseconds, right?
That's correct, yes.
This is the current waveforms, the ISC standard, set up in order to simulate the amount of energy coming from the different origin of sources. So in the case of conduction, when we do have direct lightning impacts in our installation, the standard set up a waveform named as 10-350 microseconds, which means that in 10 microseconds, we are getting the 90% of the total amount of energy, and then in 350 microseconds, it's reduced by 50%. Then, in the cases where we do have sources coming from induction or internal sources, the waveform stated by the standard is the one named as 8/20 microseconds, which means that in 8 microseconds, we are getting the 90% of the total amount, and then in 20 microseconds, it's reduced by 50%. The key here is to get this overlap in between both current waveforms to see, and at the end, the aim behind these waveforms is to see that the worst scenario, the worst energy generating scenario, is the one coming from induction. That is the one belonging from direct lightning strike impacts in our installations where we do have a lightning rod in place. So then, with the slides we've shared with you with the different type of SPDs, this is why in the SPD type 1, that should be able to discharge current ratings coming from direct lightning strike impacts, the scenario of conduction with the waveform 10-350, it should declare the IM, that the IM was the parameter referring to the waveform of conduction according to the standard. It's not that easy to explain it right now. Perhaps with the presentation, I will forward it to you, Christo. You can share it with customer, and if there is any further question, I can help to clarify. At the end, the waveform are coming from the standards, and thanks to these waveforms, the standard set up the parameters every manufacturer should fit to assure the SPDs are type 1, type 2, or type 3, according with the robustness once they are discharging current to earth coming from over voltages.
Okay. Perfect. Thank you for that.